All right, let me talk about just a couple of minor points related to applying Archimedes' principle, or just some things to sort of increase your intuition for how things actually work. So Archimedes' principle says that the buoyant force is equal to the weight of the fluid that was displaced by the presence of an object, right? Um, so note that that means that it doesn't really matter how shallow the water is or how big of a body of water that something is in. That the amount of buoyancy or the buoyant force provided in those two situations does not really depend on the body of water itself. It really only depends on the size of the object and how much of it is immersed. So, like in this picture, this object, even though it's in shallow, small container, has exactly the same buoyant force as this object in a much larger container. And in fact, because the mass of water doesn't because the density of water doesn't change very much with depth, the weight of the water displaced by this object is almost exactly equal, or is exactly equal to the same the amount of water displaced by this object. And therefore, these two objects actually experience the same buoyant force. The only exception to that, which is something kind of interesting, is that objects that are on the bottom of a container, so watch this. Let me see if I can move this. So imagine that I have this object, though, that's sitting over here. This object's a little bit different. So whereas these objects all have a bottom side where fluid pressure can be exerted from the bottom, this one doesn't. And so actually it turns out that this object does not have the same buoyant force as the other ones. And it's basically because there's no way for pressure to come up from the bottom. So in that case, Archimedes' principle is not true. So if you have an object that is sitting on the bottom of something and hasn't detached from the fluid yet, or from the floor of the fluid yet, or the floor of the container, then in that case, actually, like this object is actually does not have as large of a buoyant force as these objects. Because the pressure from the bottom can't be accessed. So this has important applications in, for example, salvage. So like if you're trying to salvage something off the bottom of the sea, the force you initially need to lift it off is bigger than what you need once it's off the seafloor. But the important bit here is that all of these objects have exactly the same buoyant force as one another.